All right, so here's another exercise. This one is very different than when you'd see on the test, just because it never says you have to use the normal approximation to the binomial. But this exercise, if you read through the question stem, feel free, by the way, to try this on your own, especially read through the question stem and translate it before I work through it with you. So there's 3 different values given to you in this question stem. We have our probability of success, right? In this case, teens having nasal allergies, which is our probability of success or our true proportion. We have a random sample, so we have our sample size. And then we have a number of teenagers who ended up in that sample having that. So we have an X. This is our count of successes, right? This is our X. So those are the 3 different things given to us. And we know that our success is nasal allergies, and we could check bins if we wanted to, right? Binary outcomes, nasal allergies or not. Independent, they were randomly selected. Yep, random sample. And, well, that's our fixed number of trials. And our S, our probability, is 65% regardless. So we have our binomial. Ah, that got so big. Come on, shrink, shrink, shrink. Cool. So when asked for the distribution here, there are 2 correct answers. One is X follows a binomial. That's what we just said, right? We have an N and a P, so this is a binomial experiment. So X is binomial with an N of 0.400 and a P of 0.65. Now, part B says let's find a mean and standard deviation. Since this is for our number or binomial, we'd again go to our formula sheet. We grab our mean and standard deviation for a binomial off that sheet, and we could calculate these. Remember, Q is just 1 minus P, so 400 times 0.65, 260, and then we want to take the square root of that 260 times 0.35. I'm just lazy, don't want to write the whole thing out. 9.5394, 9.5394. So there's actually a second correct answer to A. If you look through some of my old tests, you'll see this is a multiple choice I'll sometimes give. Choose all of the following. The second correct answer is that we could say X follows an approximate normal with this mean and standard deviation. And we can say that because if we checked our rule of thumb, our NP is 260, and our NQ is going to be the other 140 people, and those are both greater than 10. So we can actually say X also follows an approximate normal. So both of those are correct. Now the last question here, and this is why I said this is not something I would ask on a test. If this was a test question, in fact, there would only be one part. It wouldn't have multiple pieces. It would just say, use the normal approximation to the binomial to find the probability of having 285 or more people. In this case, it just says, is 285 unusually high? So 2 ways you could do that. You could find a z-score, right? 285, how far is that from what we expected of 260? Right, we know that z-scores around 2 are unusual. So this looks like we are 15 away divided by 9. We're going to be between 1 and 2, so somewhat unusual. Another option is to figure out a probability of getting that. So if we got 260, if we expected 260 and we observed 285, how likely is it that we would get 285 or higher? And we do need to say or higher because remember the probability of 285 by itself is 0. And if we wanted to be really cute about this one, if we wanted to use normal approximation, normal CDF to find this area, right? Lower bound is the 285. Upper bound is E99 with a mean of 260 and a standard deviation of 9.5394. Now, if we want to be really good, if we want to include 285, that means we actually want to step just slightly below 285. So if we wanted to be clever with the continuity correction here, we would use 284.5. So that way we actually include 285. So with the continuity correction, I cannot type today, 284.5, E99, oops, 260 to 9.5394. Oh, I forgot a comma. It is so hard to type on this stupid ass thing. There we go. 0.0051. So even though this z-score wasn't terribly extreme, this probability is insanely low. So I would say yes, because only a 0.5% chance of getting that many people. So again, not something I'm going to expect you to do on the exam. On the exam though, what I will expect is that we can find this mean and standard deviation and then find a probability. So let's see, I think maybe the last one is probably the most similar. I don't know. I don't think I have one very much like an exam question. You'll have to look through the old exams for that.